Hey everyone, Max here. Welcome to the Building AI Agents tutorial series. Over the next couple videos, we're going to deep dive into what AI agents are, how you can build them using N8N, a powerful workflow automation tool. By the end of this video, you're going to know what an AI agent is, and you'll have built a simple AI agent in N8N, which means that you'll know how to use the chat trigger, which is going to allow you to send messages through UI and send it to an AI agent. You'll know how to configure the chat model for that AI agent. You'll know how to configure memory so that your AI agent understands the context of a single conversation over multiple messages. And we'll also touch on user messages and system messages and some best practices around those, because a lot of the success of an AI agent solution comes down to the prompting. This is going to be primarily a hands-on course. We're going to be in N8N building out AI agents. But just to contextualize all this, we are going to do a quick few definitions and context for newcomers. So if you're familiar with AI agents and have built them in a different tool or perhaps coded them out yourself and you're looking to just understand how to do it in N8N, you can skip this section, but we should be quick. I'll also call out that I expect that you have some very basic technical understanding. So you know what an API is, you know what a variable is, but you don't have to be an expert coder. I most certainly am not, and I almost never write lines of code. GPT does that for me these days. To frame what we're doing, let's first define what an AI agent is. And to do that, let's quickly define what a large language model is, right? So a large language model generates text based on input text. It's basically trying to guess what the next word is based on what you input. So it's a function, right? Input comes in, output comes out. An AI agent, on the other hand, builds on top of what an LLM can do by adding goal-oriented functionality. That's that task completion that we were talking about. It also has the ability to leverage tools and other such dependencies. In short, an LLM model just takes some input text and output text, versus an agent can take your input text, feed that into an LLM, make multiple thoughts under the hood. Those thoughts can decide to use a tool. It could use that tool. It can ingest the output of that tool back into the LLM and decide what that next step is. And then finally decide in those many steps, once it has the final answer, once it has completed your task, and output that. Now, there's dozens and probably at this point hundreds of different tools and frameworks and systems that help you build AI agents. We're going to focus on using N8N to build our AI agents. And in short, N8N is a workflow automation tool where you can build workflows with multiple steps. We call them nodes, and some of those steps can be AI agents. Now, the really neat thing about N8N workflows is not every step of a use case needs to be solved by an AI agent. If the first step in your workflow is to receive an email and check if it's valid, there's probably a really simple regex function you could run to check if it meets a certain set of rules. Relatively speaking, it's going to be a lot more expensive and laggy to try and use an AI agent for that job. So the nice thing about using a tool like N8N is we have the flexibility to combine these deterministic steps, the things we do with traditional programming, with the power of LLMs to process things like natural language and also multimodal use cases, right? So images, audio, video, that sort of thing. Now that we've got the definitions out of the way, let's open up N8N and build our first AI agent. So I'm here in my N8N account, and I'm currently inside a project, but if you're in your home section, this view is going to look very similar. What we're going to want to do is to create a new workflow. So we'll do that. Now, in my blank workflow, there's this add first step action that I'm going to click, and this is going to open up what we call the nodes panel. The nodes panel is where you access all the different nodes in N8N that you can use to build your workflow. So think of a node as a step in your flow. The first option here that we need to decide on is how we trigger the workflow, how it runs. For this example, we're going to build a classic chat assistant. So the user is going to type something in, the AI agent is going to take that, perform its task on that message, and send back a response. So to do that, let's pick this on chat message option, which is going to add the chat trigger to the N8N canvas. This is just one way to start an AI agentic workflow. You could use a webhook or hundreds of different triggers, but this is a great way to get started because this chat trigger is integrated with N8N's chat UI, so we can actually test it inline, and once it's ready to go, we can also publish that. And then once we're ready to activate this workflow, we'll be able to access a public version of this UI. So basically creating your own ChatGPT. This trigger node's job is essentially to collect the user input and send it along to the next step. So let's click this plus button here. And again, we're going to open up the nodes panel. For most of this tutorial series, we're going to be hanging out in the advanced AI section, but there's hundreds of other nodes. For example, if you want to fetch something from an app before the AI step, or do various conditional logic and whatnot. And it then has all those sort of key parts ready for you when you need to build that out. So let's go into the advanced AI section, and we're going to want to add an AI agent. There's various other options here for really specific use cases. For example, if you need to extract information from a certain input or analyze sentiment, most of these you could achieve with an AI agent. These are just more opinionated if you're doing that specific use case. So let's go ahead and click the AI agent to add it to my workflow. Once I add the AI agent, there's going to be a few things that we need to set up before we can run and test this. So the way AI agent nodes work in init-n is they have one or more dependencies that they need to run. The chat model is always required. This is the LLM that's going to use under the hood to process semantic text and to think, so to speak. And then there's various other options that we can also add. Since the chat model is required, let's set that up first. But throughout this series, we'll get into all the different dependencies and options available for AI agents. So to add a chat model, let's click this plus here. Now, there's various different models that you can connect. If you'd like to self-host LLMs, Ollama is going to be a great way to go. And it then has a self-hosted AI starter kit you could leverage for that. And that's going to let you leverage dozens of open source models that you can run on your own hardware or on your own bare metal. Since I already have an OpenAI API key, I'm going to go ahead and add the OpenAI chat model because I'd like to use some of their models. So let's click on that. The first thing you're going to want to do is to add your credential. Now, in init-n, credentials are separated from workflows, so you can have credentials in one spot. For example, here I've got my OpenAI account that I'm leveraging in each one of my workflows that needs this chat model. But if you're opening this up for the first time, when you click this drop down, there's going to be the Create New Credential button. You're going to click that. In here, you're going to have to add your OpenAI API key. That's out of scope of this video, but if you're not sure how to do that, a quick Google search should help you there. And you only need an organization ID if you belong to various organizations. So for most folks, you won't have to fill this in. So once you have that API key, hit save and you should be good to go. And then for most chat model nodes, you will select the specific model that you want to use. So here we could use GPT-4o, for example. And then there's also options here. Now, I'm not going to go into every single option, but if you're ever reading an article on how to tweak some settings in an LLM to get the results that you want, those are usually going to be found here in the options. So now that we have our chat model set up, we can test our AI agent using the chat button because we're using a chat trigger here. So if I click this, let's just write hello, and we can see it's running. And let's have a look at these logs. So what's happened is we can see we got a response from our AI agent. Hello, how can I assist you today? If we open up my AI agent, what we can see is we've got some input data. This is from our chat trigger here. We can see it sent along a session ID. That's going to be great in future when we're setting up some memory. The action, so this was a send message, and then the chat input. That's the message that we just wrote. And then we have some of the settings for our AI agent here that we're going to configure in a sec. And we can see the output. This is the message that it outputted there. So inside a node, as you can see, we've got the input data that comes into a node. We can set up the settings of that node to configure it how we want it to complete its step. You can reference input data to do that, to give it context, and then it outputs something. So let's have a look at the important parameters when setting up the AI agent. So there's the agent type. This is the first option here. Its default is the tools agent, and we're going to focus on the tools agent throughout this tutorial series because it's the most advanced and comprehensive init-n AI agent available today. There are a few others, but with the tools agent, you can basically achieve a lot of what these other ones are doing. I recommend for most folks, unless you really know what you're doing, just stick to this as your default. The first option here is the prompt source. You can think of this as the user message, and if you don't know what that is, we'll explain in a moment, but this is basically the task that we're asking the AI agent to complete. So AI agents take a task, a question, and they try to answer. They try to complete the thing they were asked to do. In here, the default is take from previous node automatically. So what this does is it expects in its input some input data with the key of chat input. So if I go over to JSON view here, we can see this is actually how the data that's coming into this node is represented. So we've got one item of data coming in, and it's got this chat input top level text variable here. That's set to hello. So as we can see, that's what it's referencing here. Now I could override that. I could click on prompt source and change it to define below. And then here I could type out static text. So I could say, here is my task, right? And now if I run this, Of course, please go ahead and let me know what task you'd like assistance with. It's responding to this text here. In short, be it using the chat trigger and automatically piping that in through the taken from previous nodes automatically option, or through define below, it's in this text or this text from previous node where you're defining the task, the thing that you want your AI agent to accomplish. Now, there's a few other parameters that you can use to control how your AI agent completes your task, but one of the most important ways to control the results and the output and basically the efficacy of an AI agentic workflow is with what is called the system message, which you can add from the options in here. So if I click to add that, you can see it does have a default message, which is you are a helpful assistant. So we're going to cover a few best practices for system messages, but I could do a whole multi-part tutorial series on system messages themselves. So know that this is general guidance and it will depend on your specific use case. Nonetheless, there are some best practices that you can abide by. Before we get into those, you can see already we've got two basically places where we're providing text to our AI agent to modulate or to inform how it's going to complete the task, right? So we have the prompt source or the user message, as it's called in some of the docs you might read for AI models. And then we have the system message. So what's the difference between the two? So in the user message goes the actual task, the instruction for the thing that you want done. And then the system message defines the context, behavior, and rules for how that task should be completed. Think of the system message as an instruction manual on the tone, perspective, and functionality of how basically your AI agent completes the tasks it's asked to do. Crafting your user messages and system messages are what's collectively known as prompt engineering. Now, again, that could be a whole tutorial series, and in fact, it is an entire profession. So let's cover a few basics right now to get you started, but we will do more of a deep dive throughout this tutorial series. So my bare bones checklist when I'm creating system messages is it should define the role of your AI agent. This can be a direct voice, like you are a helpful assistant. For example, this is the default message here. It's defining the role of the assistant. The next thing I typically like to provide is the style. So this is the tone. A great example might be concise and avoid jargon. That's telling it how the output should sound, what words it should gravitate towards, what length of the text it should be outputting. And then the last part of my simple checklist is to make sure that you're adding boundaries to the task. Now, obviously that can look different from task to task, but a great example of boundaries would be don't hallucinate. That's something, if you've been in the AI space for a little bit, you've definitely heard these prompting hacks like don't hallucinate, which improve results of these LLM agents. A more tangible example of that could be something like ask clarifying questions if you're not sure what the user wants to ask, or don't make assumptions. The system message is a great place also to include static context, especially with these newer AI models that have very large context windows. So an example of a static context could be the time right now. The GPT model that we're using right now does not know what time it is right now. In the system message, this is a great place where we could add that kind of static context. Static in the sense of it's not something the AI agent's using as a tool at runtime. So to add this context, we can actually use NNN expressions. So I'll switch this to an expression. And what this is going to let me do is basically combine JavaScript with my static text, very similar to how a mail merge might work in a email marketing program. To do that, I'll hit open parenthesis, and we see NNN's autocomplete here. And I can use the now variable here, and I'll add that, and this is including the date timestamp here. Now we can see it's including this date time here. I could write something like today is, and now we have the date and the time and even the time zone. So if we run this again, what date is it today? We can see that today is November 26th, and that is correct. That's when I'm shooting this video. So that's a very simple example, but it shows how we can add context as a system message, how we can modulate its response. Another great example could be output in German. So now when you ask what date is it today? Heute ist der 26th of November. My German's not that good. And as you saw, I'm just writing these in sentences here. Grouping this by sections and different syntax around prompt writing is definitely helpful. Here's a quick example template you can borrow already today, but we'll get into the details in future videos here. We've added a chat model. We're sending in the user message, and we're also feeding in context in the system prompt and modulating the tone or the output. so that it's in German. Now that we've got the basics working, let's have a look at these other dependencies and see how we can leverage those in our AI workflows. So memory gives your AI agents statefulness. So the way a chat model works today is if I send in a message, its job is to predict how to complete the output. It's a function, right? I send in some text, it will output some text. It does not remember memory and context. And when you use tools, for example, like ChatGPT, it's actually using a memory functionality under the hood and remembering your messages together. And then when it sends it to their GPT model, it sends a stack of those messages so that it has the extra context. That's what end-to-end's memory feature does as well here. So you don't have to manage that stack. To highlight this, let's try to have it remember some stuff between these executions, and we'll see that it's not able to do that. So let's change this back to English so I can communicate with it. And let's give it something that it has to remember. So the number is 3. What is the number? So it should reply with 3. Okay, the number is 3. Now, if I ask what is the number, it's not going to know what I'm talking about because it does not know that this happened. So let's change that by adding some memory. I'll click the plus here. We have a few different memory options. So the easiest one, as it's labeled here, is the window buffer memory. Let's click the window buffer memory. Now, how memory works at a high level is it expects a session ID. Every time you reference the same session ID, it finds that session and it'll append that latest message to that session, creating basically an array of messages or a stack of messages. The way it works in end-to-end, if you're using a chat trigger, is there's really nothing to set up. By default, it's taking the session ID from the previous node. We're auto piping in that session ID. You could, however, define that below, but let's keep it on the default now. And then the default context window length is 5. This means it's only going to get the last 5 messages, which for now is fine. But if you're doing a chat-based use case, you're probably going to want to bump that up. So now that we've attached some memory, let's try that example again. So let's say the number is 5. What is the number? We can see we've run the memory as well. So we check that. Okay, the number is 5. Great. What is the number? The number is 5. So now that we've run something with multiple dependencies, we can see how the logs could be useful here. Here we see the order in which the AI called its various dependencies. So we can see at first, it used the window buffer memory and added this message to the buffer. Under the hood, it also checked if there was any messages previously. There wasn't because we had just added it, right? And then made the call to the OpenAI chat model and then to the window buffer again. Now we have an AI agent that can respond to your task using a chat model. And it has statefulness, which means it can remember a chat session and multiple messages, so it has that context as well. Let's say we've tested my AI agent and it's ready to go. Admittedly, this is not the most sophisticated example, but let's say we built it out and we want to publish it. We want to use it in prod, so to speak. What we could do is double click on the chat trigger and make the chat publicly available. And we can copy this URL. And then what we're going to want to do is save the workflow and activate it. This is going to make sure that that public URL we just copied is live. So now if we go to a new tab and enter that URL, we can see this chat UI, which is being served by my end-to-end workflow. And so here I could ask, what is the time right now? And because we're feeding that in as context, we can see that it's giving the right time. Now, there's some defaults in here, like the text and whatnot. Those can be customized in the chat trigger. You can also attach some authentication on top, so you can ask someone to have to enter a username and password before they use this form, which is super useful if your AI agent can interact with your proprietary systems, which we'll cover in the next video when we get into the tools that the AI agents can do. And end-to-end's chat trigger can also handle various options like allowing the user to upload files and whatnot. So there's options for all those sorts of things as well. These aren't complicated settings, and there's documentation for this stuff as well. So just go check that out if you're curious on any of those details. Now that the workflow is active, if we go over to the executions tab, here we can see the various executions of this workflow. If there's a beaker icon next to it, it means it was a test execution, which means that we ran it in this editor. Otherwise, if there isn't one, it means it was a production execution, which in this case means it was run through this web UI here. There's a super useful feature that I'm going to call out when you're inspecting your production runs and you want to perhaps iterate on your AI agent or troubleshoot an edge case. When you have your execution open, this is true for an error execution or a successful execution, is you can copy the data of this workflow run to the editor. So if I copy to editor, I can now open up my AI agent and I can see the state of its data when it ran. I can see the logs from when it ran as well. It's useful for troubleshooting and iterating once you've published your AI agent. That's all for part 1 of the Intro to AI Agents tutorial series. In part 2, we'll explore setting up tools for your AI agents so they can interact with apps, services, databases, and even perform mathematical operations. This series is part of my work at NetN Studio, where we build AI and automation projects in public. So make sure to subscribe to catch part 2 of the series when it comes out and for updates on future projects. I'm Max. Catch you in part 2.